Okay, hi guys, Miss LeCompte here, Algebra 1 Semester 1 exam review video. Chose some music that I personally really love, several songs I like, and I'll put them in the description, as I've been doing. We're going to focus specifically on direct and inverse variation with this video. However, let's start off by taking a look at what we're going to do to prepare for this exam and the benchmark. Okay, first of all, how do you study for a math exam? First of all, you need to know your topics. You have to have a clue about what's actually on the exam. You're going to use your benchmark blueprint to do that. If you've lost it, you'll see it on the next slide, and I'll go ahead and I'll add it to the post with this video as a PDF. And you can also use your graded work, your Units 1, 2, 4, and 5 tests. You didn't have a Unit 3 test, and all your exit quizzes that are graded. You can use all of that to help you prepare. Remember to study what you need and not what you want to study. As you go through the blueprint, you might find some topics like, oh, those are easy, or even the dreaded, those are fun, because yes, math can be fun. You may find that you know how to do things. Don't study that. You already know how to do the stuff that you already know. You need to work on the things that baffle you. That's the best way to prepare. You're going to complete practice problems until you get several answers right in a row. And my goal for me always was 5 or more. Okay, you make that determination yourself. Work through problems with a friend, making sure that you help each other and not just give each other answers. And post your questions on Edmodo, and I will post PDFs of worked problems if you need them. All right. Here is the blueprint for your exam. 25 questions, or excuse me, for your benchmark, 25 questions. What's on the exam will be similar to what's on the benchmark, but we're doing those exam reviews in class as well, and you'll see plenty of that in class. So I know that some of these are kind of jargon-filled as we read down, but some of them are quite straightforward. So just to run through, the equations and inequalities section would be solving equations, solving inequalities, and that's what you have up here in these first couple. Justifying steps is using your properties to say what, okay, that was the addition property of equality or whatever. Real-world problems mean word problems, so it's always potential to see some word problems. Probably not as difficult as the ones we've done in class, probably a little bit easier, the ones they give you. Slope of a line, finding it from a function, finding it from 2 points in the line, finding it from the graph of the line, writing equation of a line. So all of our linear equations topics right in there. For functions, determine whether a relation represented by a set of ordered pairs, a table, or a graph is a function. We just have gotten done doing an activity where you were matching all that up. Identify domain and range. Zeros, we'll talk about. Intercepts, we know what that is. Zeros we'll talk about in class briefly. Direct and inverse variation, that's SOL 8. And that's where we're focusing the rest of this video today. And then the curve of best fit or line of best fit we'll be practicing next class. And then making predictions we'll also be practicing. And we have done a little bit of that, but we'll do some more of that. All right. Direct and inverse variation. Let's review the concept first. When x and y vary directly, they follow the formula y equals k times x, where k is the constant of variation. This should look familiar. We should remember this. Our example that we did in class was our shower example, if you recall. It was the one where we talked about the number of hours, or not the number of hours, the number of minutes you're in the shower and the number of gallons of water that you use. And we found that it was represented by the equation, if x is the minutes and y is the gallons, y equals 3x. Turn this one up a little bit. Everybody loves this song. Okay, you can use a proportion to solve a direct variation equation. We have been practicing with those, and you can absolutely use the proportion, and proportions are a little bit easier for us, so generally we do like to use them. And really what you would do is you would set up your proportion like so, where the two ordered pairs match, x1 and y1 and x2 and y2. For an inverse variation, when y and x vary inversely, they follow the formula y equals k over x, where k is still your constant of variation, but you have a different circumstance. In the direct variation, as one value goes up, the other one goes up, or vice versa, as one goes down, the other goes down. But remember, for inverse, it's opposite. As one goes up, the other goes down. You can use the formula x1, y1 equals x2, y2 to solve an inverse variation. Better for me than a proportion, because we had some trouble setting up the proportions correctly, and we had some trouble getting them to come out right. This will always work for an inverse variation. Let's practice some problems. Okay. If you know this stuff and you got this down and you want to pause it and try it out, fine, fabulous, go for it. I trust you. But definitely look at the answers and listen to my fun, witty commentary. Listen to the Jackson 5 in the background there once you're done with the problems. But I'm going to go ahead and go through and write them out now. Okay, if y varies directly with x and y equals 8 when x equals 4, find y when x equals 6. This is the perfect kind of problem set up for a proportion. So that's what we're going to use. So we have y equals 8 when x equals 4. So if I write this as 8 over 4, that's y over x. X. For the other ordered pair, the other set of values, we're going to put, again, y over x. We don't know y, and x is 6. Cross multiply to solve. 4 times y, 4y. 8 times 6, 48. Divide both sides. And what's the value of y for the problem? It's 12. Awesome. Next one. If y varies directly with x and y equals 3/2 when x equals 1/4, find y when x equals 2/3. Now you can again use a proportion, and this is one of those moments when your graphing calculator is super useful. But I'm going to use the equation, so you've seen one example done each way. Y equals k times x is the basic formula for the direct variation. So that means in this situation, 3/2 is equal to k times 1/4 or 1/4 k. How will I solve that? How will I find the value of k? Well, I would multiply both sides by 4. Okay, that's a times sign. Just came out kind of messy. Our 4's cancel here. And we end up with k equals 3/2 times 4. 3/2 of 4 is 6. So my k value is 6. Oop, x. Okay, that's supposed to be an x. All right. So my equation for this direct variation is y equals 6 times x. When x equals 2/3, find y. So we're going to take y equals, and we're going to plug in our value. And remember, we've been seeing this with systems of equations too. If you have one of the variables and you want to find the other, all you really need is an equation. Because as soon as you plug in one variable like this, you can find the other. So 2/3 of 6, that would be 4. Okay, going back to make sure I did that right. Looks good. Okay, and see if you notice a pattern in number 2 that might help you find that answer without actually having done all that work. Okay, application problem. The height of an object varies directly with the length of its shadow. Height of the object varies directly with the length of the shadow. So we could say height equals k times L, or length. A 6-foot tall person casts a shadow that's 8.5 feet long, or 8.5 feet long. So if I solve for k, here I'm going to divide by 8.5, and I'll show you a cool shortcut right here. Of course, if I have a calculator, 6 divided by 8.5 is no big deal. But if I don't have a calculator, it's going to frustrate me. So let me switch colors real quick so you can see this little this method I use here. All right, so it's 6 over 8.5. If I multiply both of those by 10, I get 60 over 85. That gives me a fraction that I can simplify to find k. Dividing both of them by 5, I end up with 12 over, 17. And there's our k value. Y equals 12/17 x. So I'm making this in my classroom and the heat just turned off. 4:30, like clockwork. And yes, it does get pretty cold in the evenings here in the building. That's why you should thank your custodians for their hard work, because they do it in the cold during this time of year. But now I guess the music's probably a little easier to hear, I hope. This is a Simon and Garfunkel song I really like. Anyway, back to work. All right. Okay, so at this point, I have my equation right here, and I want to plug in the 38 for the length of the shadow. So we're going to put that in for x. Uh-oh. Did Miss LeCompte make a mistake? I don't think she did, but well, that'll have to remain to be seen. I'll pause it in a few minutes and double check for you. If I go ahead and I plug in the 38 and I solve this right here, I simplify this, I'm going to divide, I can't divide anything, so I have to do 12 times 38. I guess I'll have to write it out. All right, 2 8s, that's 16. 8 and 1, that's 9. 3 2s, that's 6. 3 1s, that's 3. All right, so if I add that straight down, that should be 456 over 17. Gosh, what an awkward value. Well, what would you normally do with that at that point? Well, what you would do is, since this is supposed to be the height of a person, you would just go ahead and divide. And what is 456 divided by 17? And yeah, I know, I have a calculator. It's not really cheating though. We talked about this, right? It's using your resources. Let's round off to the nearest tenth. The tree is 26.8 feet high. Last slide, last example. Switch to inverse variation. If y varies inversely with x, and y equals 2 and x equals 7, find y when x equals 28. So yes, I can use the formula y equals k over x for these, but I really, really like that equation I showed you on the previous slide. And that's what we're going to use this time. You multiply x and y together and set it equal to the product of the other x and y. So this would be 7 times 2 equals 28 times y. So that's 14 equals 28y. Divide both sides by 28. 14 over 28 is 1/2. And that's our answer. Stopping to notice that as x got bigger, y got a lot smaller. Awesome. This is another one that's really well suited to this method. X times y equals x times y. And I am again going to pick up my calculator. I have no complaints with you using a calculator. We're at the point where we're using our resources rather than just writing out decimal multiplication where we could make a mistake. And I don't need a calculator for this part, because 27, if this was 27 and this was 54, it would be easy. That's just 2. And remember, we can treat it the same way. So y equals 2. Last one more application problem. We're now listening to Ben Folds. He's one of my other favorite musicians. I like a lot of music, if you haven't noticed. Anyway, the time t needed to complete a task varies inversely as the number of people working on the task. The time t needed to complete the task varies inversely as the number of people. Or time times people times number of people equals time times number of people. So that will also work, just like it did for the first two. It takes 5 hours for 7 workers to do a job. How long will it take, so we don't know the time, for 10 workers to do the job? So that's 35 equals 10t. Divide by 10. 3.5 hours. Makes sense, right? More people takes less time to do the job. If you know that you need more practice with direct and inverse variation, I'm going to include a link to this website that I told a couple classes about right here. So you can feel free to write it down if you want. braingenie.ck12.org. And this link it's going to be in the assignment description. When you click on it, there's some cool practice problems, and they have you telling whether or not a set of ordered pairs is a direct or an inverse variation, and finding the equation for it, regardless of which one it is. And they're excellent consumer applications, and there's some other cool stuff on the website. If you find anything good on there, definitely let me know. I hope you have a wonderful weekend. Happens to be my birthday weekend, January 12th, my birthday. I share my birthday with several famous people. Most of them are people you probably wouldn't know. But I wouldn't have a problem telling you who they are in class. And hey, see, that's what I just said to get you to make sure you're listening to the audio. Because now, if you didn't listen to the audio, you're never going to know who I share my birthday with. Have a great weekend, guys. I'll see you in class.